Hello, guys. Let's talk about a really exciting topic, a mole or Avogadro's number. So, it is the same as a dozen. We know that 1 dozen of something is actually 12, right? Now, similarly, 1 mole of something is actually 602 hexillion. Really large number. Why do we need this large number? Well, when you are counting eggs and you know that you have 1 dozen eggs, it's really easy to count that, hey, I have 12, right? You can count bananas, you can count elephants. But what if you are trying to count molecules? How do you count how many molecules do you have in a tablespoon of sugar? Well, it would be really crazy to use a dozen to count it, right? Because you have a lot and a lot of molecules, because molecules are teeny tiny. So that's why we use moles to count the number of molecules. Okay, so let's break down what is 602 hexillion. Okay, so 602 hexillion actually has 21 zeros after the 602. Would you like to punch it into your calculator when you are doing your calculations? Not really, right? Because it would be a pain to put in all the zeros. However, we can use scientific notation to give this number. And this number is actually called Avogadro's number after Amadeo Avogadro's work, who was an Italian scientist. Okay, so let's try to do the scientific notation for 602 hexillion. Let's move the decimal place from here up to having just one digit before the decimal place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so I moved my decimal point by 23 places, right? So this means that I can show 602 hexillion as 6.02 times 10 to the 23rd because I moved my decimal point by 23 places. Okay, let's put 602 hexillion into perspective. If we would spread 1 mole of marbles, which is 602 hexillion of marbles, over the Earth's surface, we would produce about a 3 miles thick layer. That's crazy. That's a lot of marbles. We would be all covered by marbles. But if you just take the number of atoms, if you take 12 grams of carbon atoms, it's actually going to be also 602 hexillion carbon atoms, and 12 grams would fit in your palm, right? So again, atoms are teeny tiny, so we need moles to count them. All right, so let's try to put this into perspective and use moles the same way as if we would be using a dozen. So if I have a dozen cars, how many cars do I have? 12, right? Okay. If I have 1 mole of cars, how many cars do I have? Avogadro's number, 602 hexillion, or 6.02 times 10 to the 23rd cars. Okay? All right. So if I have 1 dozen cars, how many tires do I have? We know that each car has 4 tires, so I simply take the 1 dozen, which is 12, and I multiply that by 4. It's going to give me 48, so I know that I have 48 tires. Okay, now what if I have 1 mole of cars? How many tires do I have? Well, the same way, I just take 6.02 times 10 to the 23rd cars and multiply that by 4, right? Because in each car, I have 4 tires. So that is going to equal to 2.41 times 10 to the 24th tires. Okay, so 2.41 times 10 to the 24th. Okay, I hope this makes sense. Let's move into molecules. So, if I have 1 mole of CO2 molecules, how many molecules do I have? Avogadro's number again, right? So I have 6.02 times 10 to the 23rd molecules. All right. Now, if I have 1 mole of CO2 molecules, how many oxygen atoms do I have in all those CO2 molecules? Well, in each CO2 molecules, I have 2 oxygen atoms. So, if I know that I have 1 mole of CO2, which equals to 6.02 times 10 to the 23rd CO2 molecules, I can actually write out a conversion factor. So the conversion factor would be just a fraction, okay? So if I want to cancel out the number of CO2 molecules, the number of CO2 molecules will go on the bottom, and I'm looking for the number of oxygen atoms. So the number of oxygen atoms goes on top. I know that in one CO2 molecule, I have 2 oxygen atoms. The CO2 molecules cancel out. My final unit is oxygen atoms, and I know that I simply have to multiply 6.02 times 10 to the 23rd by 2. And this is going to give me 12.04 times 10 to the 23rd oxygen atoms. Okay, again, 12.04 times 10 to the 23rd. Okay, I hope this makes sense. Let's do another one. What if I have half a mole H2O molecules? How many oxygen atoms do I have in there? So I know that in 1 mole of H2O molecules, I'm going to have 6.02 times 23rd molecules of H2O. But what happens when it's just half a mole? I can again write out a conversion factor, and let's do that. So if I have 0.5 mole of H2O, I can cancel the moles of H2O out, right, by putting it on the bottom of my conversion fraction. And on top, I'm going to have the number of H2O molecules. So I know that in 1 mole, I have Avogadro's number of H2O molecules, which is 6.02 times 10 to the 23rd H2O molecules. Okay, my moles cancel out. Now I have to go from the number of molecules into the number of oxygen atoms. And again, I can use a conversion factor. Now I have to cancel out the number of H2O molecules. So H2O molecules go on the bottom, and oxygen atoms go on the top. Okay, how many oxygen atoms do I have in one H2O molecule? 1, right? So for one H2O molecule, I'm going to have 1 oxygen atom. So if you do this calculation, you will find that the number of oxygen atoms in half a mole of H2O is just simply 3.01 times 10 to the 23rd oxygen atoms. So 3.01 times 10 to the 23rd oxygen atoms. Okay, I hope this makes sense. Avogadro's number is extremely useful in the lab because we don't want to count each molecule one by one, but we can count them as a mole. And remember, a mole is not scary, it's just like a dozen, right? is just a significantly bigger number. And do not confuse, mole does not mean molecule. Mole is just the measure of how many of something you have, just like a dozen. Okay, one more thing. So, Avogadro's name is very, very important. He was a very impactful scientist. But if you look around in stores, you can actually find avocado's number. Okay, don't mix the two things up. Avogadro is an awesome scientist. Remember his name, but you can maybe use avocado's number too. Just remember that Avogadro's number is 6.02 times 10 to the 23rd. See you in the next video.